Alrighty, let's talk average rate of change. I'm on question number 6. Part of the reason I wanted to do this question is because there's a typo right there, so let's scribble that out. That should say from 0 to 7. What is the average rate of change from when x is 0 to when x is 7? All right, first thing I want to do, let's figure out where x is 0 on the graph and where on the graph x is 7. Ooh. All right, there we go. All right. Here's my x-axis. Where on this x-axis is the 0? Where on here is 0? I believe it's right here. Here is where x is 0. I'm going to draw a slice in my graph where x is 0. The other thing I'm looking for is where is x 7? Here's my x-axis. Where on here is 7? It looks like if we go to the right 7, here is where x is 7. I'm going to draw another slice. Now, the great news about this is that now that we have this interval, I do not care about anything else on this graph. All I care about is what's inside the interval. And then even further, I really don't care about the full interval. I only care about the part of the interval that has this piece of the line in it. What I'm going to do next is I'm going to mark off where does the line cross the boundaries for my interval. And it looks like it crosses right here and it crosses right here. Let's figure out what the coordinate points are right there. Remember, a coordinate point goes x comma y. So basically, how far to the right did I go? Well, I'm right on the axis, so it looks like I went right 0. And then how far up did we go? Ta-da! Looks like we're up at 9. All right, for the next one over here, again, an x and a y. Okay, how far to the right did I go? Well, it looks like I went 7 to the right. And then how far up did we go? Oh, well, we're still right on the line. It looks like we didn't go up any, so I'm going to say 0 there. Now, the part that a lot of kids mess up on this one is now that we have these two great coordinate points, now that we have these two great coordinate points, what do I do with them? Well, let's try and remember there's a fancy equation that goes with this problem. M equals y2 minus y1 over x2 minus x1. It looks like I've got some x's and some y's, but this says x2 and x1, like there's those subscripts there, those tiny little numbers. Well, great news, those aren't too hard to handle. This is my first coordinate point, so I'm going to say this is x1 and y1. This subscript just tells me that this is my first coordinate point. This is the x value that goes with my coordinate point. Because it's the first one, I need my first x value. This y value has a 1 because it goes with the first coordinate point. This is our first coordinate point. First coordinate point. Because it's the first coordinate point, it has these little ones that go with it. This one down here, this is our second, let me do that a little bit better, our second coordinate point. Coordinate. I think I might have spelled that wrong, but that's fine. All right, since this is our second coordinate point, I'm going to put an x2 and a y2 because it's the second coordinate point. Now, for the rest of this problem, all I got to do is figure out, all right, inside this equation, what goes where. It looks like the first thing I need is y2. If I look at my coordinate points, y2 is 0. So I'm going to say 0 minus, oops, I don't know what happened there. There we go. 0 minus y1 is 9. So I'm going to write 0 minus 9 over, it looks like next up I need x2. x2 is 7, so I'm going to write a 7 on the bottom here, minus, and then I need an x1. It looks like x1 is 0, so minus 0. If I figure that out, 0 minus 9, that's negative 9. 7 minus 0 is 7. That's my answer, and that's what I'll write right here for number 6. And done. All right, this is kind of a tricky concept, so let me know if you still need help after this. Maybe watch the video once or twice to try and make sure you understand this one. Talk to you later.